Hey everyone. If you're getting ready for the AP Computer Science Principles exam, here's the deal. The multiple choice section has 70 questions, you'll have 120 minutes to finish it, and it makes up 70% of your total score. The free response section, which we covered in the last episode, takes 60 minutes and counts for the remaining 30%. Now, preparing for the MCQs isn't just about memorizing facts. Every question tests both what you know, the big ideas, and how you think, the computational thinking practices. The big ideas are topics like coding, data, networks, and the impact of computing. The practices are your problem-solving tools, like writing algorithms, analyzing code, or evaluating innovations. Master both, and you're set up to crush the exam. As you'll see in the donut charts on screen, not all content and skills are tested equally. Understanding which areas carry the most weight can help you study smarter. So here's the strategy. These questions blend concepts and skills. Instead of spreading your time evenly, focus on where the biggest overlaps are. Two combos dominate the test. Algorithms and programming paired with writing or analyzing code impact of computing, paired with evaluating computing innovations. That means you should get confident reading and writing pseudocode. Understand how programs process and use data. Be ready to explain how tech affects society, the good, the bad, and the unintended. Prioritize these hotspots and you'll be well prepared for more than half the exam. Let's break each one down. Before we dive into the key content and skill combinations, let's review some general best practices to help you succeed on the multiple choice section. First, practice regularly. Familiarity with the exam format enhances confidence and efficiency. We'll provide sample questions in upcoming episodes and in the resources section to help you sharpen your skills. Next, be strategic. Always answer every question. There's no penalty for guessing, so don't leave any questions blank. Pay attention to question types. Some questions require you to select 2 correct answers. These are scored as all or nothing, so ensure you select exactly 2 options. Use process of elimination to narrow down choices, especially when uncertain. Group-related questions. If multiple questions are based on the same code or passage, tackle them together to save time and mental energy. Familiarize yourself with pseudocode. You'll have access to a reference sheet during the exam, so memorization isn't necessary, but practicing with it is beneficial. We've included a QR code to the sheet for your convenience. Pay close attention to keywords. Words like best, not, most likely, or least can significantly alter the question's intent. Finally, stay calm and pace yourself. You have approximately 1 minute and 42 seconds per question. Some questions will be easier than others. If you get stuck, skip the question and return to it later. Keep these strategies in mind. They'll give you a strong edge regardless of the content. Now, let's explore the high-impact combinations you should focus on. To work smarter, we'll concentrate on 4 essential areas that offer the most impact on the AP CSP exam. 1. Algorithms and programming. Big idea 3. This is the core of coding, understanding how to write and analyze code using loops, conditionals, variables, and functions. 2nd, impact of computing. Big idea 5. Explore how computing affects society, including topics like privacy, security, and the digital divide. Expect questions that assess your understanding of these impacts. 3rd data, big idea 2. Grasp how data is represented and manipulated, including binary numbers and data compression techniques. 4th, computational solution design. Practice 1. Learn to design and evaluate computational solutions effectively. We'll utilize sample questions from the College Board to guide our study of these areas. Before we dive into the big ideas and practices, We've pulled a set of sample questions straight from the official AP handbook to use as practice material. You can scan the large QR code to take the quiz online. You'll get your score instantly after submitting. Prefer working on paper? Use the smaller QR code on the right to access the original PDF version. Go ahead and pause the video now, complete the questions, and come back when you're ready to review. Now let's walk through some of the questions that align with our top 4 focus areas. Starting with question 3. This one involves pseudocode loops and robot movement. At a quick glance, the image on the left shows a clear pattern. The robot is zigzagging across the path, taking more steps with each turn. If you've practiced loop logic before, you might recognize that when we use a counter like n equals n plus 1, it usually goes at the end of the loop, not the beginning. So, based on that, we can eliminate choices A and C. Next, we notice that the robot only turns once left and once right for each zigzag segment, which means it's not looping through multiple turns. That leads us to choice D, which best matches the pattern and logic of the loop. Takeaways. Use process of elimination. Watch out for the loop counter's location. It can completely change the behavior of the code. And most importantly, look for visual patterns in questions like this. They often give you big clues before you even read the code. Hopefully you were able to write out the condition. Age greater than or equal to 16 and age less than 18. But when you look at the choices, that exact expression isn't listed. And that's okay. Just from this, we can eliminate at least one option. In fact, that rules out both B and C. Now let's focus on the remaining answers. Both A and D include option 2, which we know is correct. Let's quickly check option 3. Age less than 18. That's true not. Age less than 16. That's logically the same as age greater than or equal to 16, which also checks out. So that confirms the answer is D. Takeaways. Use process of elimination. Even if your exact answer isn't listed, write it out first to clarify your thinking. And make sure you're solid on Boolean logic. It really matters here. We'll be posting a separate study guide on Boolean expressions soon, and we'll dive deeper in a future episode if there's demand. Let's break this one down step by step. We're given a list of numbers indexed from 1 to n, and the goal is to count how many values are greater than 100. Steps 1 and 2 are already done. We set up the counter and check if the current item is greater than 100. What's missing are the steps that let us move through the list and repeat the process until we've checked everything. So what do we need? We need to check every item in the list, not just stop when the count hits a certain value. And we need to make sure we're incrementing the position variable so we're not stuck on the same element. Let's look at the choices. Choice D doesn't update the position, so we'd keep checking the same element. That's definitely wrong. Choice A and choice C both stop when count gets high enough, which might be too early and could skip valid items. Choice B increases the position after each check and keeps going until position is greater than n. That's exactly what we need. It checks each element once and stops at the right time. Final answer. B. Takeaways. Use process of elimination. Make sure your loop visits every item, though don't stop too early. Always update your loop variable and double check that the logic matches the goal of the algorithm. For logic questions like this, one of the simplest strategies is to plug in the values and trace the code step by step. In choices A, B, and C, the variable x is not the largest, so the first if block that checks if x greater than y and x greater than z doesn't run. That means we move on to the second conditional block in each case. In A, since y is greater than z, the second block correctly sets max to z. In B, y is the largest, and it's correctly set as the max. In C, y is still the largest, and again, the max is correctly assigned. Now for D, x is the largest, so the first condition is true, and max is set to x. But here's the catch. The second block is another separate if, not an else if. So even though we already set max to x, the second if still runs. It checks if y greater than x, which is false. So it skips to the else and now sets max to z, which is wrong. This makes D incorrect, even though it might seem fine at first glance. Final answer, D. It's incorrect because of how the second if-else runs independently. Takeaway. Don't just glance at the structure. Plug in the numbers and follow the logic line by line. Use process of elimination and watch carefully for differences between if, else, and else if, and standalone if blocks. These small structure changes can make a big difference in how the logic runs. This one tests your code analysis and debugging skills. Hopefully you notice that the count variable is being reset to 0 inside the loop. That means it starts over every time, so it never adds up correctly. As a best practice, a counter like this should be initialized outside the loop, not inside. That way, it keeps its value across all iterations. So the correct fix is choice C. Move the count left 0 line above the loop. Final answer, C takeaways. Always watch for where variables are initialized. Putting them inside a loop can accidentally reset their values. Use code tracing to simulate what happens each time through the loop. These types of questions are all about understanding the flow of control and scope in your code. Notice that this question has 2 correct answers. It asks you to draw 3 circles, each with a center coordinate and a radius. Let's start by writing down what we expect. 4, 2 with radius 1. 4, 3 with radius 2. 4, 4 with radius 3. Now we'll go through each answer choice by plugging in the values and tracing the loop logic. Choice A draws the first circle at 4, 1 with radius 0. That's clearly wrong. Choice B draws at 4.2. Radius 1, 4.3. Radius 2, 4.4. Radius 3, exactly what we want. Choice C goes in reverse. 4, 4, radius 3. 4, 3, radius 2. 4, 2, radius 1. That's also correct, just a different order. Choice D flips the logic in a way that doesn't match either pattern. Plus, we already found 2 valid answers, so we know D isn't correct. So the correct answers are B and C. Takeaways. Write down your expected output first so you know what to look for. Plug in values and trace the code step by step. Use process of elimination. Even spotting one mistake can rule out a choice. And remember, sometimes more than one answer can be right. Check them all. On the digital exam, it should be obvious because it will have checkboxes instead of radio buttons. Here's another 2 answers multiple choice question. In this question, we're working with Boolean variables. The original expression is result equals val1 and not val2. That means result is true only when val1 is true and val2 is false. Let's walk through the choices and see which ones match that logic. Choice A starts with result equals false, then uses nested if statements. If val1 and if not val2, set result equals true. That matches the original logic exactly. Keep A choice. B also starts with result equals false, then says if val1, set to true. Then if not val2, set to true again. Problem here, it sets result to true even if only one condition is true, not both. This doesn't match the original AND logic. Eliminate B choice. C, if val1 is true, set result equal to true. Else it checks if val2 is true, then result not more false. Otherwise true. Too many paths where result can end up true even if val1 is false. Doesn't reliably match original logic. Eliminate C choice D. If val1 is true, then if val2 is true, result equals false. Else, result equals true. If val1 is false, result octagon is false. This matches val1 and not val2 perfectly. Keep D. Final answer. A and D takeaways. Focus on the truth table. And with not is only true when val1 equals true and val2 equals false. For logic problems, trace all paths and eliminate cases that violate the condition. When in doubt, plug in true to false values and test the output step by step. This question asks how a phishing attack could target a user who set up a smart home device using their personal email and password. The key is in choice C. The user receives an email that looks like it's from the manufacturer, asking them to click a link and enter their password. That's a classic phishing scenario, tricking the user into giving up their login info on a fake website. So the correct answer is C. Takeaway: phishing, tricking users, usually through fake emails or websites that seem legitimate. Be sure to know your cybersecurity terms, and questions like this rely on vocabulary. Don't worry if it's new to you. We'll include a glossary of key terms in future episodes to help you out. This question is all about the digital divide, which refers to the gap between people who have access to technology and the internet, and those who don't. Let's quickly break down the options. Choice A allows students to bring their own calculator, but not everyone may have one. It could make the gap worse. Choice B lets students bring tablets. Again, that favors students who already own one. Choice D recommends students buy powerful computers. Not every family can afford that. Choice C is the key. The school provides a device to all students, making sure everyone has the same access. So the correct answer is C. Takeaway: the digital divide is about unequal access to tech. Policies that give access to all students, regardless of their background, are the ones that help close the gap. Equity isn't just about having devices. It's about making sure everyone has the same opportunity to participate. This is another question that comes down to knowing your technology and cybersecurity terms, especially multi-factor authentication. Multi-factor authentication means using 2 or more different types of credentials, like a password and a fingerprint, or a code sent via SMS. The correct answer here is clearly choice D because it doesn't use any secondary verification. It just locks the user out after failed attempts. That's a security policy, but not multi-factor authentication. Takeaway: multi-factor authentication equals using 2 or more different types of verification to log in. Make sure you know your vocabulary, and terms like this can make or break your answer. Also watch out for keywords, in this case, not, so you don't accidentally quick pick one of the other answers. Don't worry, we'll break down more key terms for you in upcoming episodes. This question is about understanding how binary numbers increase. The last student ID is 100100011. To get the next one, we simply add 1, just like we do in decimal, moving from right to left and carrying over as needed. 100100011 plus 1 becomes 100101100 in binary. So the correct answer is A. Takeaway: binary works just like decimal. You can add 1 to move to the next number in a sequence. We'll revisit binary to decimal conversion in a future episode to help you get even more comfortable with it. This question is about knowing the difference between metadata and data in a digital photo. The actual image data gives you details like colors and shapes, useful for analyzing what's in the photo. But metadata tells you things like the date, time, and location it was taken. So, if the goal is to know where or when the photo was taken, not what's in it, that's a job for metadata. Choice B is correct. Figuring out if the photo was taken at a public event is all about time and place, which metadata provides. Takeaway: metadata equals data about the data, like time, location, and device info. Use metadata when the question is about context, not content. Knowing what metadata includes helps you avoid picking answers that need visual analysis. This question asks how to minimize the time it takes to run 3 processes using 2 processors that can work in parallel. The goal is to split the tasks between the 2 processors so that they finish as quickly as possible. The best way to minimize total time is to balance the workload. Processor 1 runs X, 60 seconds, Processor 2 runs Y, 30, and Z, 50. Total equals 80 seconds. Both processors start at the same time, so we finish when the longer running processor is done, which is 80 seconds. So the correct answer is C, 80 seconds. Takeaway: in parallel processing, the total runtime is determined by the processor with the heavier load. To minimize time, try to balance the task durations across processors as evenly as possible. His question tests your understanding of how binary search works on a sorted list. Binary search cuts the list in half with each step, so the number of comparisons grows logarithmically, not linearly. To estimate the maximum number of steps, calculate log base 2 of 500, which is about 9. Even if you don't know how to calculate logs, you can simulate it by cutting the list in half repeatedly. 250 to 125 to 62 to 31 to 15 to 7 to 3 to 2 to 1. That's 9 steps. So the closest answer is A minus 10. Takeaway: binary search is not checking every element. It's highly efficient. It takes at most log 2 of n steps to find a value in a sorted list. If you don't know logs, just follow the cut in half pattern. Important reminder: binary search only works on sorted lists. In the practice exam, we saw 3 questions tied to a case study about a company upgrading its support system software. On the actual AP CSP exam, you can expect 5 questions tied to a single passage about a computing innovation. These questions focus on 2 key skills. Practice 3, Abstraction in Program Development. Practice 5, Computing Innovations, how to prepare and approach these questions. 1. Understand the format. You'll read 1 passage and answer 5 single select questions. Often there's a diagram or flow chart, so be familiar with symbols and logic flow. 2. Practice the content. Read real-world tech examples. Review procedures, parameters, abstraction, and how they appear in pseudocode and flowcharts. Know one-based list indexing. It's used in AP pseudocode. 3. Use smart test strategies. Answer all related questions together. Don't waste time rereading the passage later. Use process of elimination. Watch for keywords like not, best, or except. They can change the intent of the question. Always guess if you're unsure, as there's no penalty for wrong answers. Once you practice a few of these, the structure becomes predictable. The key is staying sharp on coding logic and reading carefully. In this example, you'll notice how important it is to follow flowcharts and logic. These questions test your ability to compare systems, track logic, and spot what's new or different. A great strategy is to identify what stays the same and what changes in the process. And remember, always try to answer all 5, or in this case 3, questions while the passage is fresh. It's way more efficient. Notice the keyword least. That means we're looking for the option that's least likely or most unlikely to be true. In this case, common sense tells us that a company's computers and IP addresses, which are considered private information, wouldn't belong in a public-facing support system. So the correct answer is C. This is another question that asks for the least likely outcome. So we're looking for the option that doesn't make sense based on the passage. Let's go through each choice. A describes a clear benefit. That's something the new system provides, so eliminate it. B doesn't really make sense. The new system has an option for non-human responses, so it's not something that would be less likely, and it's expected. C makes sense based on the features described. D is a little tricky. It uses a double negative, unable to mistakenly select the incorrect department, which basically means users are able to route correctly, which is true based on the department routing feature. So the best answer, the least likely outcome in Mozart, is B. Takeaway: watch for keywords like least, not, or except. They flip what you're looking for. Read all options carefully, especially ones with double negatives. When in doubt, eliminate what makes sense, and what's left is your likely answer, even if it's confusing at first. This question asks which option presents the most likely data privacy concern with the upgraded system. Let's think logically. In the new support system, customer conversations and issues are stored in a call session database. That means sensitive personal information could be recorded. Choice A highlights exactly that. If someone gains unauthorized access to the database, they could see private customer info. Choices B, C, and D mention more far-fetched risks like malware, tricking the system, or stealing encryption keys, none of which are part of the system design described. So the best and most realistic privacy concern is A. Takeaway: focus on the actual design of the system. Don't get distracted by unlikely technical threats. If the system stores user conversations, then the privacy risk is data exposure, not malware or hacking tricks. On the AP exam, always choose the most realistic concern, not just the scariest sounding one. This question is about how data is sent over the internet, and the key concept here is packets. The correct answer is A. Each packet contains a piece of the actual data, along with metadata like the destination address, which helps route the packet through the network. So the answer is A. Takeaway: internet data is broken into packets, each carrying both data and metadata. Metadata is used for routing, not for encryption, file organization, or bundling. This method makes internet communication efficient, even if packets take different paths to get to the same destination. Make sure you're familiar with key computer and networking terms. We'll break those down in a future episode. Thanks for joining us for this AP CSP multiple choice strategy and practice session. We hope you found the exercises, walkthroughs, and takeaways helpful as you prep for the exam. We'd love to create more content to support your learning, so please scan the QR code and let us know which topics you want us to cover next. And don't forget to like and subscribe so we can all stay sharp and get fit together.